Welcome back everyone to this channel. In this video, we're going to be talking about statistics, and we shall begin with measures of central tendency. So the first of the measure of central tendency we're going to talk about is the arithmetic mean. If I have a set of numbers x1, x2, x3 till xn, that means there are n numbers in this set. The arithmetic mean of this set of numbers, which is x bar, is the summation of these numbers divided by their count. That is the number of numbers in that data. And for short, I can say summation x all over n. What if these numbers have frequencies? Let's say their corresponding frequency are f1, f2, f3 to fn. The arithmetic mean is the summation of the product of each number and the corresponding frequency divided by the sum of the frequency. It will now be f1 into x1 plus f2 into x2 plus f3 into x3 up till fn into xn divided by f1 plus f2 plus f3 plus fn. And for short, we can say this is summation fx all over summation f. So this formula will work to determine the arithmetic mean for a data or for a distribution where we have numbers and their respective frequencies. Let us answer the questions on the board. We have the first two questions now. The first question says, find the mean of the set of numbers. We have the numbers on the board. The average or the arithmetic mean of these numbers is add up all the numbers together and divide by their count. So if I add up these numbers, 3 plus 4 plus 5 plus 2 plus 1 plus 3 plus 4 plus 5 plus 3 plus 4 plus 2 plus 1 plus 3, that's 40. Okay, let me just see. Because of space, I will shorten it. 3 plus 4 plus 5 plus 2 plus 1 plus, okay, are you following me? Plus, I can just take the last 2 plus 1 plus 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 numbers here. If I add all the numbers together, I will get 40 divided by 13. Okay, divided by 13. That's 3.076. 3.0769. So one decimal place, it will be 3.1. Now, look at the second question. The table below, which is this table, shows the number of students who obtain different marks in the test. These are the marks and these are their respective frequency. What is the average mark? The average mark is simple. The formula says summation fx divided by summation f. So that's what I'm going to do now. 0 times 2 is 0. 1 times 3 is 3. 2 times 4 is 8. 3 times 6 is 18. 4 times 1 is 4. 5 times 4 is what? 20. 6 times 2 is 12. 7 times 2 is 14. What else? 8 times 1 is 8. 9 times 3 is 27. And 10 times 2 is 10. It's 20. I will now divide by the sum of the frequency. 2 plus 3 plus 4 plus 6 plus 1 plus 4 plus 2 plus 2 plus 1 plus 3 plus 2. If you add up all the numbers at the numerator, you will get 134 divided by, we'll now add the ones under it. This is 10, okay. This is another 10, that's 15. 15, this is 19, 20, this is 24, 25, 25 plus 5 is 30. That is equal to what? This is 4.466. So to one decimal place, it will be 4.5. To one decimal place. This is the arithmetic mean. All right, let's answer this question. Just keep watching, okay? This is the third question. The table below shows the frequency distribution of data. If the mean is 43 over 14, now to find the value of y. It's easy. The mean is a data with frequency, so it is summation fx all over summation f. Now the mean is 43 all over 14. What is summation fx? 1 times y plus 2, that's y plus 2. 2 times y minus 1, of course, that will be 2y minus what? 2, right? Because 2 times y is 2y, 2 times minus 1 is minus 2. 3 times this, that will be 6y minus 9. Because 3 times 2y is 6y, 3 times minus 3 is minus 9. 4 times this, that will be 4y plus 16. And lastly, 5 times this, that will be 15y minus 20, right? All divided by the sum of the frequency, y plus 2 plus y minus 1 plus 2y minus 3 plus y plus 4 plus 3y minus 4. Let's add. Y plus 2y is 3y. 3y plus 6y is 9y. Okay, 9 plus 4, that's 13, so we have 13y. 13 plus 15, that's 28. So we have 28y. 2 minus 2 is 0. 0 minus 9 is minus 9. Minus 9 plus 16, which is 16 minus 9, is 7. 7 minus 20 is minus 13. Y plus y is 2y, plus 2y is 4y, plus this is 5y, plus this is 8y. Okay, we have 43 over 14. 2 minus 1 is 1, minus 3 is minus 2. Okay, this minus this is 0, so we have minus 2. Let's cross multiply. So I will multiply this by this. 43 times 8y, that's 43 times 8. 344, so we have 344y. 43 times minus 2 also, that's 86, minus 86. 14 times 28, that's 392. 14 times minus 13, that's minus 182. Okay, this is 392y. That's this times this, okay? So collecting like terms, it will be 344y minus 392y equal to minus 182 plus 86. So what is 344 minus 392? 344 minus 392, that's minus 48y. Then what is minus 182 plus 86? Which is 86 minus 182 is minus 96. So divide both sides by minus 48. So if I divide that by 48, that's equal to 2. So y is equal to 2. Let's go ahead and solve some more problems, this time around under group data. Let's answer this fourth question. We are given a distribution of marks and their frequencies. So determine the arithmetic mean within what we call the midpoint. Look at it. We have the marks. And their respective frequencies. I want to put a frequency here. 5, 10, 25. This is 30, 20, and 10. Okay, this is what I want to call the midpoint. And let that midpoint be x. So the midpoint, that is the number in between. Between 0 and 10, we have 5. You can just say 0 plus 10, 10 divided by 2, 5. 10 plus 20, that's 30, divided by 2, that's 15. And this will give me 25. The midpoint of 20 and 30 is 25. This is 35. The midpoint is what? 45. And this is 55. So in the next column, I will determine the product of the midpoint and the frequency, SF or FX. 5 times 5 is 25. Okay. 15 times 10, that's 150. 25 times 25, that's 625. Okay. This will give me 550. Let's deal with it. This is 900. 3 times 5 is 15, take away 1. 3 times 3 is 9 plus that one is 10. 1050. Yes. The summation of all the numbers in this frequency column is 100. And the summation of all numbers here is 3,300. You know, for a data with frequency, arithmetic mean is summation fx all over summation f. Summation fx is this, 3300. Summation f is 100. Divide this to get 33. This is the arithmetic mean of this distribution of marks. Alright? Let's see the last question that we have under this arithmetic mean. This question has to do with assumed mean. Sometimes we may be asked to determine the mean of a distribution when there is an assumed mean given, or we can be asked to determine the assumed mean ourselves. In this case now, we are given a distribution of wages of some employers in a certain company, and the assumed mean is 74.5. But we are asked to determine the actual mean of this distribution. So using this assumed mean, how do we do it? It's simple. Actually, if we are given assumed mean, let's say the assumed mean is A. Okay, the actual mean of that distribution, x bar, is the sum of the assumed mean and the deviation from the mean. That's the mean deviation. And that is summation FD all over summation F. Here's the formula we use to determine the actual mean of a distribution when an assumed mean is given. So we'll now prepare a table in this format. We have wages. You know, we don't normally deal with the wages, we deal with the midpoint. Alright, we have the midpoint. Okay, then we also have the frequencies. Then we will now determine the deviation. And the deviation is the x, the number, which is the midpoint, minus the assumed mean. And then we will now determine the product of the frequency and the deviation. This is what we need. Let's get it. Alright, the wages are here. 40 to 49, 110 to 119. Just keep watching. What is the midpoint? The midpoint of 40 and 49 is 40 plus 49 divided by 2. And that's 44.5. 44.5. So the midpoint of 50 and 59, that's 54.5. So I can say this one will be 64.5, 74.5, 84.5, 94.5, 104.5. This will be 115.5, right? These are the midpoints of these wages. The frequency we have 4, 12, 18, 11, 4, 12, 18, 11, 7, 5, 2, 1. So what is the deviation from the mean now, which is the assuming? The assuming is 74.5. So we now say we subtract this 74.5 now from the midpoint. So I'll say 44.5 minus 74.5. That's minus 30. 54.5 minus 74.5. That's minus 20. So if I do the rest, if I do same for the rest of them, this is what I'll get. By subtracting this assumed mean from each of these midpoints. To get FD, we now multiply F and D. This time this is minus 120. This time this is minus that's 240, right? This time this is minus 180. This 0. This 70. This 100. This 60, and this 40. So let's add up everything here. That's minus 270. So the summation of this is minus 270. Okay. So therefore, the actual mean x bar is, I told you, the assumed mean, which is 74.5 plus summation fd, which is minus 270 divided by summation f. Okay, let's add up all the frequencies together. 4 plus 12 plus 18 plus 11 plus 7 plus 5 plus 2 plus 1. That's 60. Good, so all over 60. Of course, plus times minus is a minus, so it's negative. Okay, 270 divided by 60, that would be 4.5. All right, so 4.5. It means that we have 74.5 minus is negative, minus 4.5. And what would that be? That's 70. So the actual mean of this data is 70. So this is it for arithmetic mean, and this is how to determine the mean of a distribution where an assumed mean is given. This is it for this particular video. I hope you enjoyed it. Keep supporting by subscribing to this channel. Like the video and share it with your friends and your classmates. I will see you in the next video. Keep watching. In the next video, we are going to talk about median.